Hello, this is a demonstration video showing Intermap's link profile tool, which does an RF profile between 2 points based on receiver settings, frequency, and line of sight calculations based on our NextMap1 DSM. So the first thing you can do once you go into the Link Pro link, you basically have your web services login. So you can go ahead and log in with your proper credentials here. And once you're signed in, basically this is the basic interface here of the Link Profile app by Intermap. And anything that we'll do here in this app, this visual application here, you can of course do with API calls as well, because the API is fully available if that suits your purpose. But the basic interface here is, of course, you see the link profile. You on the left have all your input settings that we'll go through in a minute, and on the right you just have a little map of the world. And of course we're zoomed into some random location as default, but of course you can zoom out and you can see the whole world. And over here you can click on little coverage to show what the coverage of the data is. So for example, if I click on the sample NextMap1 data, you can see all the tiles that we have available for demonstration purposes for people who want to test out this account. For the purposes of this demonstration, I'm going to zoom into San Francisco here, over here in California. And I'm actually not going to do it within the demonstration tile. I'm going to do it slightly outside of it. So I'm going to actually call the real NextMap1 data in this case. So basically you can see again the coverage of it. So what I'm going to do for the purposes of this, you can click on any kind of 2 points just to show what it's doing. So if you click the draw button, you can go ahead and click on the 2 points you want, and you can select that as your profile. So if this is the profile you wanted to run, it would be ready to go to set up your other links. Or you can actually go ahead and type in some coordinates, which I am going to do. I'm going to do a profile here that's basically from the top of a reasonably tall building out through the financial district of San Francisco out to a pier to see what the line of sight might be to a user that might be standing out on that pier. So I'm just going to go ahead and enter my coordinates here. Latitude and longitude, of course. And once those are entered, got one more in here. I'll show you what the profile looks like and where the locations it's going to is. So we go ahead and select that when you're seeing it. So again, basically we've got a building over here that we're going to draw it on top of, and we're going to go out to the end of this pier here. So you can see that the profile I've just drawn right through the financial district. So once you've got your profile selected, the next thing you have to do is choose the data layer that the analysis is going to be run on. And of course, I'm looking to do this on the NextMap1 DSM. Typically, you're of course going to want a DSM so that you can see the true line of sight with obstructions and everything. The next thing you can specify is the step. This is the along track posting of the profile you're going to draw. I'm just going to leave this at 5 for the purposes of the demonstration, but you can change it, of course, to 1, whatever you might want to do for this. Depending on the length of your profile, the speed of computation is, of course, dependent on how many pixels it does, so you'll probably get a sense for what is reasonable depending on the length of your profile. This is a pretty long profile here. It's about 1 kilometer long, so sticking with a 5-meter step is going to be quite reasonable for the number of points it samples along there. The start height and the end height represent the heights, of course, of your transmitter and then your receiver that you're trying to do the link profile analysis, the RF analysis from. So the start height here, I'm going to assume that we're basically going to put a 5-meter transmitter on top of this particular building, and this height is representative of above ground. So if you are placing it on top of a building, it'll be what you specify here plus basically the surface elevation. And we're going to do an end height here of a 1 meter, assuming somebody's holding a phone in their hand, for example, out here on this pier. The corridor width and the corridor step basically represent the width of this profile that you're going to do. So if you want to have a sense of if there's something just on the edge of your direct point to point that could be obstructing your line of sight, you can specify that. So if I do a corridor width here of 5 meters, what it basically does is it does a 5-meter paintbrush, so to speak, across this line. And what you do here is you specify a corridor step. If you do this with 1 meter, what it's basically going to do is 5 parallel profiles to the center one, out to 5 meters, so basically two each direction. 5 kind of profiles that are parallel to each other to see if there's something just on the edge that could be obstructing your particular line of sight. Then you go ahead and specify the frequency of your transmitter. I'm just going to do a 1.3 gigahertz receiver in this case. And then the K factor represents the free space loss. So of course 1.3 is sort of a standard number, 4/3. If you have, known rain loss, or if you need to model for something else, you can obviously specify whichever K factor is appropriate to your scenario. You can change the units from metric to imperial if you so desire, but I'll just leave them in metric for now. So once you've got this all set up and ready to go, you go ahead and you press the profile button. And this will start computing. Of course, it'll take a few seconds because it's basically running now these 5 parallel profiles at a 5-meter step across this approximately 1 kilometer profile. So while we're waiting, and once this is done running, what it'll do is pop up with your results here. So as you can see here, we've put this little tower on top of this pretty tall building. Antenna on top of the tall building. And you can see here, the black line represents your line of sight down to this pier. And you can see, of course, all the buildings that are between this building and your end point. As you can see, we don't actually have any obstructions, which is a good thing. So this is a clean profile. This blue line represents your Fresnel zone, so that was where it calculated that free space loss to determine any kind of signal droop you'd have across the length of that profile. And the good news here is even that Fresnel zone is nice and clear. And then along the bottom here, you've got your minimum, maximum, and center profiles. So this dark red one here is representative of that straight point to point. If you had not done a corridor width and you just kept the corridor width as 1, this is the only profile you would have had, because this would have been the direct terrain profile. But it also shows you now what the maximum and minimum profiles were within that 5-meter corridor. So basically just showing you what the maximum height it hit within any one of those 5 parallel profiles, and subsequently the minimum height that it hit. And that's just at sort of perpendicular cross sections along that profile. And it gives you all the information, of course, of what you specified. And you can save this as a screenshot if you desire. But the other thing you can do is, of course, save this as a KML. So I'm going to go ahead and do that. And then you can open, of course, that KML in Google Earth or anything else or like a GIS package that you might have. So if we go ahead and we open this particular KML in our Google Earth, it's going to zoom over here to San Francisco where we ran the profile. And then we'll take a quick peek at the results here. So again, this was on top of this Belden place out to this pier. And if we zoom right in on this, you can kind of see what had happened. So we had our direct line of sight, we had our Fresnel zone, and here is those 5 parallel profiles we were talking about. With right down the middle, it also shows you the minimum and the maximum. So you can again see how it's done that corridor to see, okay, well, do we hit the corner of this building or not? Or do we hit a different obstruction in a particular point of the profile that maybe wasn't in the center that might be impacting our analysis? You can go along the profile and see what's going on. But in essence, this is what happens, and you can, of course, take a look at this in a perspective view, and you can see what's going on here as it's coming up over all these different buildings. And that concludes the link profile demonstration.